Alright guys, so in the previous videos we had seen what is a directed graph, how can we work using network X, and what is points distribution method. We had simulated that in an Excel sheet with a small network, with a small graph with just 3 nodes we had simulated. Now we are proceeding towards checking what happens in a complex network having lot of nodes and edges. So as a first step, we had created a directed graph. We had added a few nodes and edges were added randomly, simulating a coin toss. And now we had visualized the graph as well. This is what we had done till now. Now we'll get started with the actual points distribution procedure. So let me get started. The first step is you have to assign initial points, right? Initial points. That is the first step that you have to do. Let's do it. So let me say assign points. Let me call, and so once I assign the points, I need to have a list of points, right? So this node 0 has got these many points, node 1 has got these many points, and so on. I need a list of points. So let me call that as points. So I'll assign points. So to assign points, I need to assign it for each node, right? So I need the graph. So from the graph, I'll pick each node and I'll assign points to the nodes. So I need this, and as you could see the warning, undefined name. So we need to define this. So let us define it here. Define assign points, and we use the graph G. So I have to assign the points. So first, as I have said, for each node we need to assign it. So let me first get the list of nodes. Nothing but list of G dot nodes. So let me get the list of nodes, and now I have to assign it. Assign the points. So I need a array points. Let me say P. I need a list. So for each in nodes. So for each node, I have to append how many points? We had started with 100 initially, right? So let us do that same. We have to append 100, and once all nodes had been assigned the points, you return this array P. So we had assigned the points. So what have we done? We take the graph G and assign points to each node, and we get back the points. So we take the graph G, we take the list of all nodes. For each node, we are assigning 100 points initially. That's what I'm doing. I'm assigning 100 points. 100 points I'm assigning initially. This is not a hard and fast rule that you have to assign 100 only. You can experiment with different initial values. This is a seed value, as we can say. You can experiment with different seed values as well. As I have said, you can model it as a probability. You can say 1 by number of nodes. You initialize it and you can see what happens. You can try different things. So in this demonstration, let us take 100 as the seed value. We have 100 nodes. So we can have different seed values. With different seed values, the final convergence values would be different. But one thing would be the same. For example, we had taken in our 3-node demonstration that we had done with our Excel sheet, we had taken 100, 100, 100 each for each node. So 300. At the end, in convergence state, it was 120, 60, 120, that I remember. So it may be something like this. Instead of having 100 initially, if I had taken 10, the values may be different. If I had taken 25, the values may be different. But one thing that is same is, if you take the fraction 120 divided by the total 300 and 60 divided by 300, 120 divided by 300, that is 0.4, 0.2, 0.8. This is same. Something like that. Even if you take 25, 25, 25, at the end, if you take it, the individual point divided by 75, the total, you will get the same thing, 0.4, 0.2, 0.4. That distribution is maintained. So that is why I had given a hint. You can model it as a probability problem. See, the final sum is 1, if you model it, you are getting the distribution is constant. So you can model it as a probability problem, and you can mathematically you can go rigorously and prove that definitely there will be convergence irrespective of whatever be the structure of the graph or whatever be the initial state you start with. And it's also not necessary that you have to start with equal points, equally 100 each. That's even not necessary. You can even start with 10 points for one node, 500 points for another node, 300 points for some other node. You can start with any configuration. At the end, you'll reach the stable state. The stable state there was 120, 60, 120, given that we started with 100, 100, or in terms of scale down to one version, it is 0.4, 0.2, 0.4. That was the stability state. Something like that. Every graph has got a stability state. That is a mathematical result. So, okay, let us come back. So we have assigned the points, and now the next step is you should keep distributing. Keep distributing the points. So if you keep distributing the points, you would get some final points. Let me call it as final points. The converged points, you can call it as the converged points you will be getting. You will get the final points by keep on distributing the points along the nodes of graph G. So, okay, again I got a warning, undefined name. So I need to define it. So let me copy and define it here. Let me define it. Define this, and let me say, so I have to distribute the points among the nodes. So for that I again need the list of nodes. Let me say nodes is nothing but list of G dot nodes. I need to get the list of nodes. I have got it. Now I have to, okay, so we have started with our definition of keep distributing functionality. So I have to keep on distributing. As I say, keep distributing. So it is an infinite loop. So let me start in an infinite loop. So if it is an infinite loop, when will we stop? It's our wish, right? So Excel, even when we simulated, if I wanted, I can even drag it till 1 lakh iterations. You can drag it as you wish. So I'm going to give the control to the user. When he decides to stop, that will be the time he will stop. So I'm going to give the control. So till then it will be an infinite loop. So what should I do? I'll have to distribute the points to the nodes of the graph from this initial points configuration. Initially we have equal points. That's the configuration we are starting with. And we have to take that configuration and distribute as per our rule. Okay. So if you distribute the points, you will get a new set of points in the next iteration. So let me call that as new points. That will be my new points. So once I get my new points, I need to print my new points. What are my new points? I have printed. So once this new points have been obtained, you have to take this as your initial configuration and repeat the procedure, next procedure. So how would I do that? I have to say my points will be nothing but my new points. So basically what do you do? You get some initial configuration, you distribute it as per your procedure. After distribution, you get some new configuration, the new points. So take that as your base configuration and repeat it. So in iteration 2, you took iteration 1 values as your base values. In iteration 3, you will take iteration 2 values as your base value. Right. So that's what we are going to do. That's why we are doing this assignment. And now you have to decide whether to stop or not. So let me say stop. I'll say is nothing but I'm going to get an input from the user. Let me say I'll take some key from the keyboard. Press hash to stop or any other key to continue. You can have any key. I have just taken hash randomly. You can have star, asterisk symbols, percentage symbol. You can have anything. You can have anything. That's not a hard and fast thing. You can have anything. So I say you have to press hash. As long as the user presses hash, you have to continue. If you want to continue, you have to press some other key. If you want to stop, you press hash. That is the rule I am defining for the user. So I will get the input. Now given that user has given the input, I need to process it. If this stop value is equal to hash, then what should I do? I should break. I should come out of the loop. Alright, so once I have broken, so the user wanted to stop. Whatever is the value of new points, that will be my final points. So I need to return it. So I'll return new points. Right. Once I come out of the loop, whatever is the value of new points, I'll return it back. So I keep distributing. So what have we done here? We have assigned equal points initially. Not necessarily that it has to be equal. We have done equal. You can try a different variant as well. As I have said, you assign randomly some values. Then you see, you can use a random generator again. For example, from 1 to 500, you pick a random value and assign that as a point to the node. You can try different thing. We have started with the equal configuration. And after that, after you have assigned, you keep distributing the points. So in keep distributing, what are we doing? We have to distribute the points, and as a result of this distribution, you will get a new configuration. You print that configuration and take that configuration as your base and repeat that. You repeat that as long as the user doesn't want to stop. As long as the user wants, keep repeating. If he wants to stop, he'll stop. In that place, you return whatever is the new points, whatever is the last configuration you have got. So you return that. Right. So here we have undefined name distribute points. Yes, we have to define it. We say distribute points. What is the procedure to distribute? We'll have to define it. We'll do it in the next part.